Hello there. How's everybody doing? Good. Coffee, you're all up, ready to talk about Istio and hybrid clouds? Awesome. So I'm Allan Naim. I work at Google, and I work on Google Kubernetes engine.
And I'm Rohit Agarwalla. I'm a senior technical leader at Cisco.
So before we get started, just a show of hands, and the lights here are kind of blinding, so I'm going to have to really look hard. But how many people here are actually using Kubernetes day to day? Awesome. What about Istio? Okay. Who here has no idea what Istio is? All right, good. We got a slide for you. We weren't sure to include it or not, but I'm glad we included it. So from an agenda standpoint, I think when we talk about hybrid, the first thing we want to do is define what hybrid is, because there's a lot of definitions for hybrid, so we just want to make sure we're all on the same page. Then we're going to talk about some of the challenges associated with building hybrid architectures. And we will introduce Istio, just talk about it, define what it is, how it plays a role here in terms of the hybrid deployment patterns that we're looking at walking you through. And then the majority of the session is actually going to be demo. So we've got very few slides, and Rohit's going to walk through kind of a demo of deploying Istio in a multi-cluster environment. And then we'll show you a few use cases around that. So let's define hybrid cloud. You know, when I think of hybrid, I think of an organization that has a variety of applications that some are containerized, some are not. There's VMs, there's bare metal, there's all kinds of requirements associated with your applications. Some applications can easily move to the cloud, some applications need to run on-prem, but as an organization, you want to be able to support all these various environments, and you want to support it in a consistent fashion. At the end of the day, everybody wants to be in the top right. But to get to the top right could involve moving to the cloud just from a lift and shift standpoint and then modernizing, or it could be modernizing in place where you are to containers and then eventually moving to the cloud. So that's really how we see hybrid, is just the ability to spin up these environments in heterogeneous locations that each have different types of requirements associated with them, like networking and storage, but be able to run your applications consistently in those environments so that you're not using 10 different tools and you're able to be very productive as a business. So when we look at some of the hybrid use cases that we've seen out there that are very common, the first one is really about having the ability to take a monolith, break up that monolith in such a way where that piece you're breaking up can run in the cloud, but then have that piece be able to talk to some legacy system that's sitting on premise. Right, this one we hear a lot of, right? Especially companies that have systems, ERP systems, CRM systems, systems that just can't easily move into the public cloud, but you want to be able to expand your application and really drive innovation and break it up so that you're taking advantage of cloud. The other case is actually consuming cloud services from on-prem. In this case, you take a monolith, you break it up, but that piece that you've broken could be living on-prem as well, but you want the ability to consume cloud services. Ways that you can do that today very easily is using things like Open Service Broker or Service Catalog from Kubernetes to consume those various cloud services. And then the third use case, which is really, I would say the most popular one that we see, is the consistent DevOps CI/CD environment across cloud, multi-cloud, and on-prem. The ability to spin up Kubernetes clusters in all these environments, but have a consistent way of running and deploying your applications, right? And this is the beauty of Kubernetes, right? It enables you to do that. So there are examples of that I hear a lot of is you want to build your application on the cloud, but you want to have the ability to now take this application and pretty much run it anywhere, even in locations outside the cloud. How do you do that? And that's where Kubernetes definitely comes in. But Kubernetes doesn't solve everything, right? And those of you that have that are using Kubernetes probably know this very well. As I mentioned, Kubernetes does a great job of giving you that consistent environment for running, deploying, managing your applications. But then what about the ability to do fine-grained canary deployments where, in Kubernetes you can push changes and those changes go through a rolling update process. But then, as you're pushing new versions, requests are getting round-robined across, the versions that you have for your service. What if you wanted more fine-grained canary-type deployments where you wanted a certain percentage to go to, remain flowing into version 1, but then you want 10% flowing into the new version. You want fine-grained control over that. It's not really easy to do with Kubernetes. What about routing based on headers, right? Type of device that a request is coming in on, or location, or any type of URL header information that you have coming in from a request. That's not easy to do just with Kubernetes. Then you have, the cases where you want to do more intelligent load balancing, right? Random least connection across multiple clusters, right? With Kubernetes today, you can do some of that with single cluster, but when doing across multiple clusters, it becomes very hard. Cross-cluster service discovery is a big one, right? That's challenging. You have to look at implementing some kind of external DNS, and how do you manage the service names and service discovery across environments that could be on-prem and cloud. Service observability is another one, right? How do you know what the services are actually doing? What services depend on other services? Think of it like a service graph. Kubernetes is amazing in allowing us to build a lot of services, but then with all these services, we need ways of managing them very efficiently. This one's really important, service-to-service communication between clusters, right? How do you do that today with Kubernetes in such a way where your traffic is encrypted and you're dealing with identity stores or identity access management systems that are very different environments? And then dealing with unreliable networks, especially in the case where you're doing CI/CD deployments in off-cloud locations, branch locations. Oftentimes that network is very unreliable, but you want a way to be able to have more predictability and higher quality of service for those services that you're deploying in those environments. So Istio comes along, and for those of you that are familiar with Istio, experts with Istio, close your ears, look at your phones, check your email. For those of you that aren't familiar with Istio, so Istio consists of a control plane and a data plane. The data plane is really this service proxy, this Envoy proxy that runs alongside your applications. In the Kubernetes world, this Envoy proxy runs as a sidecar container in a pod. So all egress and ingress traffic to and from your application goes through the service proxy. And you use the control plane to configure policies associated with these service proxies. So for example, if you want to define routing rules in terms of, I want a certain amount of traffic to go to this version and then the rest to go to that version, I would basically define all these policies using Pilot, which is the first component of the Istio control plane. And then Pilot basically pushes all these policies out to the envoys that are running in the data plane so that all communication that's happening is based on those policies that are defined with Pilot. Then you have Mixer, and think of Mixer as really responsible for doing the health checking, all the various telemetry that's collected across the various services that are running. And then there's this component called IstioAuth, which is, now it's called Citadel. Which is really about issuing TLS certs to your proxy so that you have secure communication for your services that are talking to each other, whether it's within a single cluster or across multi-clusters or multiple environments. So Citadel is responsible for that. So just like Kubernetes abstracts away the underlying infrastructure so that you can deploy your applications consistently, Istio abstracts away the networking for your services. So the thing to keep in mind here is the applications that are running with the sidecar actually know nothing about the sidecar, right? So you can continue building those applications just as you would regularly, and when you inject that sidecar, you get all the benefits of policy around your network from an operational standpoint without having to change any code for your application.
Cool, thanks, Allan. So the next few slides, I'm going to talk about the hybrid cloud deployment patterns, specifically with regards to Istio, and then we'll jump into the demo. So Allan spoke about the hybrid use cases and also talked about like high-level Istio. So how do we combine these two things together? So in the slide, what you see here is I've got a Kubernetes cluster that's running maybe in the cloud or on-prem, but it's consuming services that are outside the mesh, right? So this is a typical example for most of the customers where they have not modernized all parts of the application, but have modernized only parts of it. And so in this case, it could be a MySQL or a traditional database that's running on the on-prem side, or while you're running something on the on-prem side, you're consuming a cloud service. So there are a couple of efforts that in the community that have taken place around enabling integration from a hybrid cloud perspective. The first and foremost is mesh expansion. So mesh expansion enables you to deploy these Envoy agents onto virtual machines or bare metal servers that are running within your environment. So in effect, these machines that are outside a Kubernetes cluster can actually become part of that mesh itself. The second aspect from a hybrid perspective is when you're consuming public cloud services. So at this point, when you are trying to go out of the mesh into a public cloud, you want to apply certain policies that say whether you are not actually allowed to consume this public cloud. Most of the enterprises actually do this in a DMZ environment or through a firewalling mechanism through which they open up ports for these cloud endpoints. Having this service mesh layer actually gives you the capability to get rid of that kind of environment and give that capability to the app ops persona that can actually define what cloud services can be consumed. The second aspect is, well, I've got most of my things running in Kubernetes or are containers, but I've got multiple of these Kubernetes clusters. So in this slide, what you see here are two or many of these clusters running across multiple clouds, maybe one running on-prem, one running in the cloud, or one running within the cloud against different VPCs or different projects, if you will. So in all of these cases, what you need is the capabilities that we just talked about Istio, that how do I actually discover services that are running across these different Kubernetes clusters, and then apply a consistent policy as I move my workloads across the different environments. From a network connectivity point of view, as you move to a cloud and an on-prem environment, it's very important that you define how your networks are connected and how your pods, IPs are getting connected to each other. And we'll talk about that in the demo as well. So the last capability of how you actually have multiple clusters running and how you do the service discovery is based on the Istio multi-cluster feature. This actually landed in .8, which is going to be released very soon. So in this feature, actually what we're doing is we're running a control plane for pilot in one of the clusters, which we call as the local cluster or the primary cluster. And then we run a headless service of pilot on the other remote or the secondary clusters. And what this does is that the primary pilot actually is able to discover all the envoys that are running within the multiple Kubernetes clusters, and you can then define the policies in terms of routing, in terms of access against all the services that are running in your two different environments. So this is the demo that we are also going to show. So let's get into the demo description as to what are the 4 things that you'll actually learn while we go through the demos. First and foremost is we'll look at the service deployment of Istio in a multi-cluster setup. So we'll look at 2 different clusters. We'll see what are the components of Istio that are deployed. Second, we'll look at the service discovery part, the aspect of pilot actually registering and learning about these different endpoints that are existing in my 2 different clusters. Third, we'll look at the microservices that are deployed. So in this case, the popular Books Info app that's available on the Istio website, we'll be deploying that. We'll be actually deploying parts of those services in the secondary cluster and part in the primary cluster. So you'll be able to see these 2 different services deploying across different environments. And then finally, we'll apply a policy using the single Istio control plane of routing against one of the services, but you can expand that to other policies as well. So these are the 4 things that we're going to cover. This is my demo setup. This is actually right now running 2 Kubernetes clusters within Google Cloud. You can effectively expand this to 2 clusters that are running across any environments, like I just mentioned. It could be 2 public clouds. It could be a public cloud and an on-prem environment. Or it could be, like in this case, 2 VPCs or 2 projects in which you have your Kubernetes clusters. The key thing to note here is these 2 clusters that I have, they are having completely separate, non-overlapping pod IP addresses. So what that means is when I'm spinning up clusters, when I'm spinning up workloads, they are getting pod IPs that don't overlap with each other. And we'll see that in the output of the demo as well. And the primary cluster is named Allan. We've been very creative about naming clusters. The secondary is Rohit. And we're deploying the Books Info app in a way such that all the components except for reviews v3 is deployed on the primary cluster. So what we'll see is, and the reviews v3 is deployed on the secondary cluster. So what we'll see is when we start the Books Info, the product page, we load the product page, it'll load against all the versions of reviews. But when we apply the policy, it will only go to the reviews v3 because I'm sending all the traffic to the reviews v3 version. All right, so let's switch windows here and go to my terminal. And actually, first let me actually show you on GKE, the Kubernetes clusters that are running. So these are the 2 clusters that are running, Allan and Rohit. Let's look at Allan first. This is my primary cluster, which has running all the Istio control plane components. And as you can see here, 1052 is my IP address range for my pods. When we look at Rohit, this has a 10.4. This is what we described. And I've got a kubectl get.
Can everybody see from the back? Should we increase the font a bit?
Oh, come on. How about now? How about now? Okay. So we'll do a kubeconfig get context to just show you what are the 2 clusters. So I've got 2 contexts. I'll switch between these 2 contexts. One is the Allan context for my primary cluster. The other is the Rohit context. So right now, with the star, I'm in the Allan context. So I'm going to now run a bunch of commands here. So what I'm going to be doing essentially is run get deploy, get services, and get pods, as well as endpoints on the primary cluster. And we'll see it's basically within the Istio system, which is where my entire Istio has been deployed, what are the services that have been deployed. And the primary one that we're going to be focusing is Pilot, which is effectively helping us discover all the endpoints in both of these clusters. Again, the output is a little muddled because of the size here, but essentially these are the Citadel, the Pilot, these are all running, and they are running 2 containers here within the pod. In case of Pilot, one is the Pilot agent itself, the other is the discovery, which is helping us actually learn all the envoys that are running. And they've got all IP addresses from the 1052. If I look at the services, again, these are defined against the pods that are running. The important thing to note here is, except for ingress, all of my Pilot services are cluster IP. So ingress has been defined as with an external IP, so this is what is associated with my ingress into the service mesh. So my product page, which is my front end, is actually able to service and let the traffic come into the mesh. And my deployment is actually defined based on the services there. And lastly, the endpoints, I think. So the endpoints, again, correlate to the pods that are running, so they all have IP addresses. It's important to note the IP address of the Pilot here, as well as the other mixer components, because when we look at the secondary cluster, you will see that we are referring actually this pod endpoint IP address in our secondary cluster configuration. So let's actually look at the secondary cluster. So I'm going to just switch my context here and go to my remote cluster. So I've just did that, and we'll now run the same set of commands that I just run and see what are the Istio components that are deployed on the secondary cluster. Anytime now? All right. So what we see here from a deploy perspective, I've just got the Citadel service running. So this is the Istio auth. In my setup, I am not actually doing any MTLS or encryption between the 2 clusters. But if you enable that in your deployment, that you will need Citadel to be running on both, as well as actually handing out certificates to the Envoy proxy so that they can load the certificates. But I'm not doing this in the setup, but I'm still running the service. Apart from that, when I look at pods, I can see I don't see actually any pods except for the Citadel pod running. And when I do endpoints, this is where you will see that I've got a pilot endpoint, policy, and stats. And you can see the IP addresses that have been given to these endpoints. So this is, how many folks actually know about headless services in Kubernetes? Okay, not much. So a headless service in Kubernetes is effectively a service without a service IP. You think about this with pods that are just having IP addresses, and you want to consume these using the pod IP addresses rather than attaching a cluster IP on top. What I've done here is I've created the headless service for pilot running on the on-prem side or on the secondary cluster. And what that does is I'm pointing all of my requests to the primary pilot. So when my envoy that is running on the secondary cluster actually queries the kubedns to say, hey, give me the IP address of my pilot, it will actually respond back with the IP address of the primary pilot, because that's what I've configured when I'm running pilot on the secondary. This enables actually a very important requirement, is that my pods need to be able to communicate with each other over an IP network. Whether you do that through VPN or non-VPN options, it's important that these two distributed clusters are able to talk to each other. Okay, so we've looked at all the setup details of the pilot of Istio in both the environments. Now let's look at the app itself. So I'm going to go back into my local cluster and look at, again, the Books Info app that I've deployed. And what we should see here, everything except reviews v3, right? So I should see my product page, my ratings, my details, all of these, and they should all have IP addresses based on the local cluster. So again, from a deploy perspective, that's what we have here. I have the cluster IP addresses from the local, and I've got all of these pods with 2 containers in them. So essentially, I'm running the app itself, and alongside I'm running an Envoy proxy or a sidecar proxy in Istio land as another container within that pod. Similarly, if I go to my remote, and I'm going to run the same set of commands, and we'll see reviews 3 as being deployed, as well as ratings. So the reason you're seeing ratings as a service here is because because the way the reviews app is defined is actually consumes ratings as well. But again, this rating is a headless service. I'm only consuming ratings from the primary cluster. So on my on-prem environment, on the secondary cluster, only reviews pod is running actually. All right, so I think that we've gone through the setup. We'll go back to the local and look at the ingress information. And this will help us actually give us the pilot registration information. So I'm just going to copy the IP addresses here. So this is, I'm getting the ingress pod name, which had the external IP address associated with it, and I'm executing into that container so that I can actually query the pilot to get all the endpoint information that are running within my cluster. So we'll run that command. And we'll run this curl command finally, now that I'm here, to actually see the endpoint information. So it spits out a bunch of output, but the key important point here is for reviews. As you can see here, within pilot, which is running on my primary cluster, I just curled that, and it gave me 3 endpoints for my reviews app. And so 52, 52, if you remember, are for my primary cluster pod IP range, but .4 is from my secondary range. So what this tells me is that my pilot is all set with 3 different endpoints. So unless if I have no routing rules configured within my setup, I should be in a round-robin way actually load balancing across all of these 3 endpoints for my reviews. So for that, let's go into our front web page. And what we see here is actually reviews 1, reviews 2, reviews 3. So these are loading the different stars. So reviews 3 is red star. It will go to reviews 1, which is no star. Reviews 2 is my black star. So I can see it's a round-robin way in which I'm load balancing against all the endpoints when I'm entering into the mesh.
So prior to point 8, this particular pattern is something that you would not have been able to do with Istio and multiple Kubernetes clusters.
Right. So this landed is going to be in .8, and .8, I think the branch is out, but the release is going to be out very soon. So the last piece in this demo that I want to show here is now when we configure a routing rule, how does this all change? And then we kind of summarize this in terms of how this is applicable in a lot of the environments that we just talked about. So what I'm going to do is I'm going to create a route rule reviews v3. And once it gets created, I'm just going to quickly open up and show you what that rule is. And what this rule does is it's essentially saying that for reviews as my destination, so which is effectively my stars that I'm loading, I want it to all go to v3 version with a weight of 100. So all of my traffic should be hitting reviews v3. So I've created that, and if I go back into my web page here and I start loading this, when I do refresh, I should only see the red stars. And that's what's happening. So I just created a rule as an apps person saying that a new version of the app that the developer developed has been posted. And since I'm an operator, I want to send all of my traffic to this new version of the app. As like Allan had mentioned in the starting of the discussion or the talk, we can actually look into the HTTP header. It could be based on users. It could be based on the device from which you're accessing your service. You can apply all of these policies for the traffic that's getting into your mesh. So now if I actually go ahead and delete this rule, I'll be able to go back into the same load balancing scheme that I had previously. So I'm going to just go ahead, delete this and come back here and just start refreshing. And as you can see, immediately the mesh took that rule into action, and Envoy got programmed with the endpoints to say, with the policy to say that now I need to load balance against all the 3 endpoints that I have been discovered in this mesh. Again, this is very useful from a policy perspective, especially as you move your workloads across multiple environments, because you can define this in a very consistent way, irrespective of what the cloud provider security groups or firewall policies are, but have Istio enable and take care of that layer for your application-to-application communication.
Yeah, and this definitely comes in very handy for just canary-type deploys where you have a target, let's just say a target cluster running in the cloud that you're using to test out a new version, and you want to trickle a certain amount of traffic to it until you feel comfortable, and it's actually, it accelerates the deployment and development process.
So I think that was the end of the demo. We can also extend this to, like I said, to an on-prem and a public cloud. There's actually a session on Friday at 2 p.m. Where we'll actually be showing this running against a Cisco on-prem and a Google Cloud environment. So you should definitely attend that, and it'll also give you a lot of details about how this is actually implemented into Istio and how we are doing the pilot enhancements. There are other capabilities that the community is also working in addition to like removing things like dependency on VPN connections for pod-to-pod communication. So the session will discuss some of that future work as well.
Thank you, Rohit.
Sure.
So to summarize what we just talked about today, the 3 points that we'd like to leave you with. The first is you can really simplify operations by leveraging the policy-based methodology that we've shown you here that Istio brings to the table to really complement the work that you're doing with Kubernetes and extend it in such a way where you can deploy and you can have control around these environments that are very different in nature. The second piece here, for those of you that are new to Istio, is just like Kubernetes makes it easier to push applications and manage applications and update applications, Istio makes it easier to connect, manage, and secure those services that are running on Kubernetes in a very, again, heterogeneous fashion. And then the third point is Istio enables you to really build hybrid service deployment patterns that can span on-prem, could span multiple clouds plus on-prem, all these various cases that just as a standalone with Kubernetes would require you to do a lot of manual work. So you get that with Istio. And I think we're right on time.
Cool.
So we can take some questions.
I guess, do you guys want to just queue up on the mic?
All right. Thanks for the talk. So one question. So is my data center running this primary pilot now a single point of failure from point of view of Istio, or do you have something in terms of a more multi-master configuration for it?
So pilot is running as a pod within my primary cluster, right? So I mean, if you want to create backups outside your primary cluster, then essentially you're backing up all of your core Kubernetes services into another Kubernetes service that is running within that environment, right? So you have to essentially treat Pilot as another service that's running within your primary Kubernetes cluster.
All right.
Sure.
Hi. Yeah. In the demo that you have done, all the traffic is routed through the primary cluster. So in case that you are just targeting the reviews version 3, all the requests go from primary to the secondary cluster. So if you are on premise, you route all the traffic from the primary to the secondary, right? That's it? There could be like a performance issue there?
So if I understand the question correctly, you're asking whether all the traffic is going through the primary cluster for reviews 3? So it's not. So the primary cluster is running all of the apps or all of the services that you're exposing to the outside. And so reviews 3, the topology is on Books.info app, is on the Istio web page, but my products page, which is effectively running on the primary environment, is talking to all the 3 versions of reviews 3. So the Envoy essentially sends direct requests to reviews 3 when I actually put in a rule, so it sends directly that to the secondary cluster. It doesn't go through any other endpoint within the primary cluster.
How did you configure the data path in Envoy to go through the VPN? So what do you do there?
So the question is, how did I configure the data path? So I think right now the multi-cluster feature, one of the key requirements is that all pods within these 2 Kubernetes clusters or multiple Kubernetes clusters need to be able to talk to each other.
Okay.
So that's the trick. And typically, when you are running within private networks in an on-prem environment and in a cloud, you essentially do a VPN. And so that's the Friday demo where you will see a VPN tunnel actually get created.
So you do the routing through the
Absolutely.
VPN.
We do that routing as well. So in effect, your pod IP ranges that are running on-prem get advertised to the Google Cloud or any public cloud. And similarly, your GKE cluster addresses get advertised to the on-prem so that these are now like one network and you're able to do pod IP to IP communication.
Thanks.
Sure.
We had a question here.
I wanted to ask, one, if you feel that Istio and Envoy is production ready, and if not, which version or roadmap for Istio? And second is if Google will provide commercial support or, for enterprise and stuff like that.
I'll answer the first, you can answer the second. From a production ready perspective, I think Envoy, we have seen multiple deployments of Envoy in production. So I think that we should consider a robust piece of the software in the puzzle. Istio is on .8, it's still not 1.0. But at the same time, I think I've seen the level of maturity improve in Istio, and there are a lot of performance as well as tests that are going into the community or into the software itself. So I would not put .8 into production, but at the same time, I would start playing with it so that when I have a version of 1.0 which is ready, I can move to a 1.0 version.
And to answer your second part of your question, yes, Google is looking at providing more of a commercial offering around this. So stay tuned. Yes. I don't have exact timelines at this point, but stay tuned.
Hey, thanks, Allan and Rohit. I have a question here. So,
Sure.
How do you see this demo working on a federated cluster, for example?
I actually don't have an answer to that question. I don't know federated clusters much.
So are you referring to the open source federation work?
Yeah. The KubeFed, for example.
KubeFed.
Yeah.
Anybody in the audience? John, he's the author for the multi-cluster work, so.
Oh, great. Thanks.
So when we first started looking at multi-cluster support in Istio, we considered kube federation.
Yeah.
But at the time, it didn't support privileged containers, so that was a roadblock. And plus, it wasn't clear where the KubeFed was going and how long it was going to last. Mm-hmm. So we did just, I just attended the multi-cluster SIG, and we need to coordinate a little bit as we move forward and evolve this technology on both sides. So I see that this will converge with that, okay. But when and how, I can't say.
Yeah. Oh, thanks.
Great, thanks, John.
I have a question. I was wondering, when you do multiple cluster Kubernetes and the IPs cannot overlap, have you faced problems with overlapping IPs, running out of IP addresses, or how did you solve that problem?
No, we have. I think most of the work, all of the work has been focused on non-overlapping IP addresses. And I think that's also because of how we are essentially defining for some of the headless services and pointing them to the primary cluster. But if overlapping IP addresses is your requirement, would love to talk more and understand your use case.
In the demo, can you confirm that if you deploy a review version 3 in the main cluster, the first one, the traffic will be load balanced to only these pods and not to the 2 clusters?
Yes. So I mean, if you deploy reviews v3 on your primary cluster, it'll effectively be load balancing on all the 3 reviews on the primary cluster. Yeah, you can absolutely do that. I mean, this is mostly a multi-cluster feature that because you have a secondary cluster, and these could be 2 different teams that are developing same version of the app, or it could be because you have a version of the app that is specific to a particular country or a region that you want to expose, but you have other apps that are common. So for those kind of use cases, you need to have these different versions running in different environments, right?
Quick question. How do you see Istio integrates with API gateway management? Is there any kind of coalescence here or similarities? Because something needs to get the traffic north to west, or north to south. Anyway, do we need another API gateway? I
think I would actually categorize Istio as an evolution of the API gateway model. In regards, because it's more distributed, you don't have a central API layer in between, but rather have these agents and sidecars that are running alongside every workload or every app or microservice. And they effectively can define what you need to actually consume. You can define your quotas, you can define your policies, which is in effect an API gateway functionality, right? So I would, but again, don't get me wrong, API gateway has its own benefits compared to a distributed Istio proxy or a sidecar proxy model. So depending upon how your application is structured and defined, you may pick one or the other option. Again, the sidecar proxy pattern has emerged very recently, given the microservices trend. And as more and more microservices come up and more Kubernetes deployments come up across multiple clouds, I think that's where you will be limited by having an API gateway, but a sidecar proxy model will become a lot more prevalent in those scenarios.
And I think eventually they'll converge. The Istio will become very much a policy engine for a lot of these API gateways that are out there on the market today. Any more questions? Going once, twice. Thank you.
Thanks.